So have you ever actually tried to get a really powerful machine learning model running inside a web browser? I mean, the promise is incredible, right? Instant, totally private, interactive AI running right there on the user's device. But let's be honest, the reality? It's usually a frustrating journey of sluggish performance and constantly breaking conversion pipelines. So how do we fix this? Well, it looks like Google has a pretty compelling answer.
For years, deploying high-performance AI on the web has felt less like engineering and more like trying to navigate a complex maze in the dark. You start out with this amazing model, but the journey to get it into the user's browser without killing performance or your own sanity has been a massive challenge. If that sounds familiar, trust me, you are not alone.
And this right here, this is what that maze looked like. This was the brittle, winding path we all used to have to take. You'd start with your PyTorch model, then you had to convert it to Onyx, then you'd try to wrestle that into TensorFlow, and then, finally, convert it all to TensorFlow.js. I mean, look at it. Every single arrow is a place where things could, and often did, go horribly wrong. You'd spend days just debugging converters instead of building your actual app.
But what if there was a direct path? A superhighway that just cuts right through that maze. Well, that is exactly what LiteRT.JS is. It's Google's high-performance WebAI runtime, and it's built from the ground up for production applications on the modern web.
Okay, so what is it really? Well, LiteRT.JS is the next big step for the LiteRT stack. And if that sounds familiar, it's because you probably know its other name, TensorFlow Lite, which has been the gold standard for on-device AI in the mobile world for years. LiteRT.JS just extends that same powerful, unified runtime straight to the web, and it uses all the latest browser tech to get you speeds that feel almost native. And when you see it side by side, the difference is it's night and day. On the left, you've got that crazy four-step brittle chain we just talked about. But on the right, that's the LiteRT.JS way. You go directly from PyTorch to LiteRT. One step, that's it. This isn't just an improvement, it completely changes the entire developer workflow. So you're probably asking, how does it actually pull this off? Well, it all comes down to three core strengths. You can think of them as superpowers that really make this thing a game changer for anyone building AI for the web.
And those three pillars are super simple to remember: best-in-class performance, unmatched flexibility, and seamless integration. So let's just quickly break down what each of these really means for you and your apps.
First up, performance. And this is a big one. LiteRT.JS is designed to squeeze every last drop of power out of whatever device your user has. If they have a decent GPU, it taps into the modern WebGPU API for some seriously fast parallel processing that just blows older WebGL backends out of the water. But what if they don't have a powerful GPU? No problem. It just gracefully falls back to a highly optimized CPU path using something called XNNPack on WebAssembly. So it's smart and it's fast, no matter the hardware. Next, let's talk flexibility, because the days of being locked into one framework just to deploy on the web, yeah, those are over. It doesn't matter if your team loves PyTorch, JAX, or TensorFlow, LiteRT.JS is ready to run your models. And that direct one-step conversion path for PyTorch we saw earlier, that is a huge deal. It single-handedly solves one of the biggest headaches in web AI development. And here's something you're gonna love. What if you already have a big existing pipeline built with TensorFlow.js for all your data pre- and post-processing? Do you have to throw it all out? Nope. You don't have to rewrite a thing. LiteRT.JS is built to play nice. It takes in and spits out standard TensorFlow.js tensors. That means you can just swap out the core inference engine, the slow part, and keep your entire data pipeline exactly as it is. It's a surgical upgrade, not a total rewrite. All right, so the tech sounds really impressive, but what can you actually do with all this power? Let's move past the theory and look at how LiteRT.JS is solving some tangible, real-world business problems today. Okay, first up, imagine a fintech or healthcare app. A user needs to upload a sensitive ID for verification. Now, instead of sending that photo straight to a server where it could be vulnerable, you can run OCR and object detection models entirely in the browser. You can find and literally black out all the personally identifiable information before it ever leaves the user's device. For things like GDPR and HIPAA compliance, this is absolutely massive. Or think about real-time video. Let's say you're building a video platform that needs virtual backgrounds or maybe a low-light correction filter. You have to apply a model to every single frame of a live video stream without causing any lag. This is where that WebGPU backend becomes absolutely critical. It's really the only way you can guarantee that smooth, professional, lag-free experience your users expect. And hey, don't just take my word for it.
Here are the numbers. To process one video frame with a segmentation model on that WebGPU backend, it takes less than 16 milliseconds. Now, what does that mean? It means you can easily run at 30, even 60 frames per second. No stutter, no lag, just perfectly smooth, real-time AI in action.
And for a final example, let's go somewhere totally different. Picture an agricultural inspector out in a remote field, no internet connection. They need to analyze crop disease on the spot. With LiteRT.JS, they can run sophisticated computer vision models right there on their tablet and get an instant diagnosis. But here's the best part. The exact same model file they're using in that web app on their tablet, it's the same file you use in your native Android and native iOS apps. No changes needed. And that single unified model format has a gigantic impact on your MLOps workflow. Think about it. By getting rid of the need to build, test, and maintain separate models for web and mobile, you could potentially slash your maintenance burden in half. That is a huge, huge efficiency gain for any MLOps team.
So let's just put it all together. The old way, it was a complex, brittle mess of converters stuck on older tech like WebGL and forced you to have separate models for every platform. The LiteRT.JS way, it's a direct, simple, and robust conversion. It's optimized for modern hardware like WebGPU. And it gives you one model file to rule them all. It lets you stop debugging tools and get back to actually building amazing applications.
And honestly, this quote right here just says it all. The ability to take the exact same model you're using on Android and just drop it into your web app, that is the dream of a truly unified architecture. It means your model behaves the same everywhere, which means simplicity, consistency, and a whole lot of power. At the end of the day, this isn't just an incremental update. This kind of technology unlocks a whole new class of applications. Apps that are faster, more private, and more powerful than anything we could easily build for the web before. So it really just leaves us with one big, exciting question. With all that friction gone, what amazing things are you going to build now that AI can truly run anywhere, instantly?